It's 10%.
And to solve an inequality, of course, you are going to do everything you normally do. Use your distributive property, combine like terms, get your variables on one side, undo addition, subtraction, multiplication, division, and then the only specialty is that if you multiply or divide by a negative number, you have to flip the inequality. So for example, negative 2x is greater than or equal to 10, if that were our inequality. To solve, we would divide by negative 2 on both sides. When you do that, you have to flip this inequality to become the opposite symbol. If it's a greater than, it becomes a less than. So this would become x is less than or equal to negative 5. So that's the only difference in solving an inequality versus an equation. And then, of course, you can draw your number line and graph it. So for this one, we would have negative 5. You don't have to put like all the little dashes. It just needs to have like the critical number on it. Usually I put 0 on there too. And we'd have a closed circle on this one because of the equal bar, and we would shade less than. In an honors class, I don't expect you to have trouble graphing, but in case anyone does, if you look at the inequality, if you make it into an arrow, it actually points in the direction that you should shade. So the one that was up here, if you make this into an arrow, it would show you what direction to shade, in case anyone gets mixed up on that. All right. So I've thrown in some fractions, and you'll notice number 2, I'm starting to make them harder. I've got a lot of brackets, parentheses, and more. Solve and graph each inequality. All right, so the first thing we're going to do is we have to distribute 2/3. No, we cannot make it 0.6 or 0.7. We have 0.6 repeating. So you want to make sure you don't ever round a decimal that shouldn't be rounded. So we're going to distribute this. Now, to multiply fractions, you don't need a common denominator. So really, this is x over 1. And 12 over 1. So you'll multiply the tops, multiply the bottoms. We'll get 2x over 3 minus 24. 3 times 1 is still 3. You want to make sure that you bring your inequality like down throughout the problem, just like you would an equal sign. All right, now, always check and see if any of the fractions actually are whole numbers. So you actually could simplify 24 divided by 3 is just 8. And we now need to get our variables on one side and our numbers on the other. Personally, I move the smaller one so that I don't get negatives, but that's just me. Some students would always move this one to this side so your x is on the left. If you do that, you'll just have to maybe multiply or divide by a negative number. But 2/3 is smaller than 1, so this is really 1x. But in order to add or subtract fractions, we're going to need a common denominator. So instead of 1, I'll just make this 3 over 3. We agree 3 over 3 is still 1? Common denominator of 3. So I'm going to subtract, this is a positive, imaginary positive, so we'll subtract 2/3 x. Make sure you realize 2x over 3 is the same thing as 2/3 x. Those are equivalent forms. And I'll come over here, I'm running out of space. Negative 8 is less than or equal to, so we have 3 minus 2, which is 1/3 x plus 8. Move our 8 over using inverse operations. And also, again, make sure that you're just careful that you bring the negative with that 8 that's over there. So we should have negative 16 is less than or equal to 1/3 x. And last step, we would normally divide by 1/3, but instead we'll do our multiplication of the reciprocal on both sides. We're multiplying by a positive 3, so you don't have to flip the sign. We should get negative 48 is less than or equal to x. Now, proper formers always have x on the left, so you will want to rewrite this with x being on the left, so you just flip everything. It'll be x is greater than or equal to negative 48. And then when they ask you to graph your inequality, just put a 0, put negative 48 on the left, because that's where it would be on a number line. And will we have an open or a closed circle on this one? Gone? Closed. And greater than? Chain to the right. You'll see that I usually do like squiggles, because if I just do a straight line, sometimes when I copy my answer key, you can't tell where the shading is, but it's up to you how you want to do it. All right, the next one we have a bunch of parentheses, brackets, and groupings. So you do want to work from the inside out, just like you would with an order of operations. Aiden?
Divide, or distribute the negative 1.
You got it. We need to distribute our -1 first. Everything else will stay the same. So this will be minus 2x, and -1 times a -7 is a positive 7. And while I'm here, let's go ahead and distribute on the other side too. Now you have options. You could distribute the 3 to everything on the left-hand side, but I probably would combine like terms first. 4x minus 2x is 2x. And then distribute my 3. So if you worked ahead, you realize we get something weird at the end of this problem. We're going to subtract 6x on both sides. And they both go to 0x. So we no longer have an x in our equation and inequality at all. So we have 21 is less than -10. Is 21 less than -10? No. This is a false statement. Therefore, our answer is no solution. If you were to graph no solution, you would have a number line with nothing shaded. No dots. Nothing. But usually I don't make you graph those. It's a waste of time. So this leads us into our next type of problem. Sometimes we won't get a solution. Some inequalities will have no solution. There's no possible number to plug in that the left side and right side would ever be satisfying the inequality. Or the inequality may always be true. And when that happens, our solution, our answer, is all real numbers. You can either write out all real numbers, or some of you might be familiar with the R notation that they use to represent. It has like 2 bars and then just an R, but just makes it a little bit more bold, and that stands for real numbers, and it's used across the board in mathematics. So you can write that instead of writing out all real numbers. All right, solve and graph each inequality. Do you think you can try these on your own? Or do you want me to go for one? Raise your hand if you'd like me to go for one. All right, give them a shot. I will tell you that their answers are either no solution or all real numbers. So no solution, again, would be if you get like 2 is greater than 1, because 2 is not greater than 1, so it's a no solution. Or sorry, 2 is less than 1. 2 is not less than 1. You would get an always true if it said 2 is greater than 1. Well, 2 is greater than 1. So if it's a true statement, then it's all real numbers. If it's a false statement, then it's no solution. That's what will happen at the end. So see if you guys can try those. Okay, let's see something I'm heard from really well. Taven, what did you get for number 3?
-2 is greater than 7 in solution.
Perfect. Just distributing. Your x's would go to 0, and we do get no solution. So literally to graph no solution, just put nothing on there. There is no answers that would be shaded. And how about for number 4? Ben.
-15 is less than 8, which is always true.
Yes. I'm sorry, I was looking at the one above. Which is always true. So our final answer should be all real numbers. So make sure you either write out all real numbers or put the R. Okay? So in case anyone got this one wrong, we had 10x minus 15 minus 7x, which is less than or equal to 3x plus 8. And combine our like terms here, we'll get 3x minus 15 is less than or equal to 3x plus 8. And then subtract 3x on both sides. And get that. Now to graph this, you would shade the whole line. Normally I don't ask you to graph them on the homework if it's not on numbers, but it would literally be the entire number line. No open circles, no closed circles, just shading on all of it. Because every single real number is a solution. Okay, remember, real numbers from chapter 1 cover irrational and rational. They cover integers, natural, whole, and rational numbers. So on the back, we will look at our compound inequalities. So you probably remember these. Compound inequalities are two simple inequalities that are joined by the words and, or. The and ones usually don't have the word and in them. If you look at example 6, which is right here on your notes, usually it's like a string of inequalities, such as like 5 is less than x plus 1, which is less than 10. Okay, that's an and inequality because you're saying x plus 1 is greater than 5 if you read backwards, and x plus 1 is less than 10. But they combine them into a compound inequality. The or compound inequalities, you'll notice if you look below, they actually always will have the word or, because it's like you're going to the mall or you're going to Target. One or the other. You can't go to both at the same time. Okay. So these ones are actually easier. You just solve two separate problems, you get two answers, and you graph them. Typically, they go in opposite directions when you shade. All right, for the first one, though, we do have the word and. So we are going to solve each one separately. We'll just combine our final answer into one of these compound inequalities. So same thing that we would normally do, just using our inverse operations. For this first one, we will subtract 1, divide by 2, and we will get 3 is less than x. Now normally we would flip that around, right? Make it x is greater than 3, but actually it'll be beneficial to leave it like that. You'll see why in a second. Solve our other one by dividing by 3. We get x is less than or equal to 6. You do need to combine these two answers into one. And you want the x to be in the middle, so it would actually be on the right-hand side of this one and the left-hand side of that one. So our final answer would be 3 is less than x, which is less than or equal to 6. This is your answer. Now to graph that, you're saying x is in between those two numbers, so it's going to be shaded in between. But we will have an open circle on 3. I found out that you can calibrate the boards, I just don't know how to yet. Mr. Powell told me that this morning, so we're going to try and find out. His was having problems as well. We'll put a closed circle on 6, and we will shade in between those numbers. Coming back to us, Algebra 1. All right, now the next one is already written as a string of inequalities. So basically when you do inverse operations, you're going to do it to all 3 pieces instead of just 2. So when you subtract 5 from this middle part, you're also going to subtract it from the left part and from the right part. So you just do it an additional time. 4 is less than 2x, it's less than 10, and then again divide by 2 on all 3 pieces. Your final answer is already done for you. You don't have to do anything else. Now you do want to pay attention. It does always have to be smallest to largest. Okay? So always make sure the smallest number comes first. And these, oops, sorry, I forgot an equal bar from up here. So always be careful, double check. And we'll graph that with 2 and 5. Open circle on 2. Close circle on 5. And again, shading in between those numbers. Now 7's the hardest one. You'll notice that we have a minus 3y in the middle, which is indicating that we're probably going to have to divide by a negative at some point, which means we'll have to flip both inequalities this time. But still, same process. What would I do first on this one? I'm going to undo addition or subtraction. Colin?
Subtraction.
Subtraction, what number are we subtracting?
2.
You got it. It's an imaginary positive 2. We don't put the plus there, so we do the inverse minus. So we have 3 less than negative 3y, which is less than 12. And now we divide by our negative 3 everywhere. And I usually write the word flip, because if I don't, I forget to flip them. So I'm going to have negative 1 is greater than y, which is greater than negative 4. Still not done. The smallest number is negative 4. The larger number is negative 1. So this is written backwards. So at the end of the problem, you have to rewrite it starting here and just flipping the whole thing around. -4 will then be less than y, which will be less than -1. So you flip the entire thing. The numbers and the symbols all get flipped. That has nothing to do with multiplying or dividing by -1. It's because our final answer wasn't in order from least to greatest. And if you went to like plot them, you would realize like -1 should be here and -4 should be there. So then once you have this, it's pretty easy. We had no equal bars, so 2 open circles. And you can always pick a number in between these, like -3, and you could plug it in and make sure that it does satisfy the inequality if you have time. All right, the 2 OR examples I think you guys actually can do on your own because it's just like solving 2 problems in one. The graphs typically for an OR will normally look like this. Okay, now there's a chance that they could overlap, and if they do, like I think there's one on the homework where it'll look like this. Oops. You will actually take it from the smaller number. It's where either of them touch. So you would actually say that the answer was x is greater than 3. Let's say this was 5. I'm just making this up. But if you got a final answer that looked like this, your final solution would be x is greater than 3 because it's one or the other. It doesn't have to be both at the same time. It's just either one that would show up. But I think these are both going to get shaded similar to this where they kind of go shooting in opposite directions. So see if you guys can solve 8 and 9. You're going to get 2 separate answers with the word or in between them and graph them. So for that one, and I don't know why my board is thinking of this circle button. It doesn't like freeze. Then we just plot those. Close circle, left, open circle, right. All right, so our last problem is one of those 3-step keystone type problems, but you also could see this on an SAT, because the SAT does cover Algebra 1, Algebra 2, and Geometry. So first at the top it says Rolando drives at least 40 miles, but less than 60. What inequality is at least? Greater than, less than, greater than or equal to, or less than or equal to? Aiden?
Less than or equal to?
Incorrect. At the very least, he drives 40. At the very minimum, he drives 40.
Greater than or equal to?
Greater than or equal to. It's the most misunderstood word in inequalities because you hear least, you think less than. It's just like the else. But it's like at the very minimum, he drives 40 miles. Really, he drives greater than or equal to. And then the less than 60, that's pretty obvious. It's a less than symbol. Graph the compound inequality representing all the possible distances that Rolando could drive in 8 weeks. So if he drives that amount each week, we would need to multiply each of those by 8 to figure out how much he would drive in 8 weeks. So we have our 40 times 8, which will be 320. I would lose points for going outside of the box. And so our compound inequality would be 320 is less than or equal to x, which is less than 480. And we'll plot those, 320 getting a closed circle, 480 getting an open circle, and shading in. So you're kind of going to be always looking at the min possible value and the max possible value, and then looking at the values in between. And then it asks you to explain why you chose the symbols that you chose for the endpoint. So I'm not going to write that out because you know my handwriting is terrible with my finger on the board. But we would say something along the lines as I chose a closed circle on 320 because it's at least, which would include the number, and I chose an open circle on 480 because it says it has to be less than, which would not include that number. And see if you guys can read through Part C while I'm passing out your homework, and then we'll... All right, who has an idea of how we can find the possible range of prices that he might owe for how much he pays in gas? Says he buys at least 8.5, but no more than 11 gallons. Aiden?
Would you add to the amount that he pays the least and multiply it by and have it X?
Yeah.
And then that would be less than X, or less than or equal to X.
I used M, I think, but yeah, say M.
Or M.
But that's fine. Oh, very
And
good.
then you would have 265X, which would be greater than or equal to M.
Okay, that wouldn't include the total number of gallons. This is the price per gallon. So you actually need to take the $2.40 and multiply, that's the smallest amount, times the smallest number of gallons that he buys, which would be 8.5. And I'll just tell you what you get there because we're short on time. And then you also need to take the largest amount of gallons he might buy times the possibility of the largest price. So you're finding the maxes and the mins of this scenario. And then you would write your inequality, which would be how you said it was, which is less than or equal to less than or equal to. All right, so homework is a worksheet again, so make sure you check